Our topic today is slope. Now, slope is the measurement of the steepness of a line. It is a comparison of the vertical change, which is called also known as the rise, to the horizontal change, which is sometimes called the run, when moving from one fixed point to another along the line. So the slope of the line through the distinct points x1, y1, x2, y2 is given by this formula here. And this is actually several different versions of the same formula. M is used to denote slope because of some kind of French word that starts with M. Anyway, this part here is read the change in. That triangle is read the change in. So this is the change in y over the change in x. The change in y would be the rise, the vertical change, and the change in x would be the run. So we also say rise over run sometimes. And then the actual formula would be y2 minus y1 over x2 minus x1. And I just noticed a typo, so let's fix that. This is supposed to be a 2. Alrighty, so here's a picture of a line with two distinct points on the line. This one over here, based on where it is located and what it says on the x and the y axis, the coordinates of that point would be x1, y1. And based on the location of this other one and how it's labeled on the x and y axis there, this point would be x2, y2. The difference between the x's is the run, x2 minus x1. The difference between the y's is the rise, so y2 minus y1. A quick summary about the types of slope that you'll see here. A positive slope has the line rising from left to right on the graph. That would be a slope value that is greater than 0, positive. A negative slope would be a line that's falling from left to right on a graph, so that would be an m value that is less than 0. Zero slope would mean that m is actually equal to 0, and that would be a horizontal line. And then the final kind is called undefined slope, and that is for a vertical line. So with this one, m is undefined. And what causes m to be undefined is when you're doing the rise and the run, and you end up with a run value of 0. That makes it undefined because you're dividing by 0 then. Okay, so we're going to find the slope of the line that passes through each pair of points here. We're going to use the slope formula to do that. So I'm just going to write it down here in the margin. My slope is y2 minus y1 over x2 minus x1. So with these, it doesn't matter which point we call x1, y1 and which point we call x2, y2. But just for simplicity's sake, I'm going to say the first one that they give me is going to be my x1, y1, and the second one that they give me will be my x2, y2. So I'll write m equals. And on the top, I need the change in the y's. So this is going to be the difference of the y values. So y2 is 5 minus y1, that's negative 1. On the bottom, it's the change in the x values. So I take x2, so that's negative 3, minus, and then the x1, that's negative 7. From here, it's just a matter of simplifying. So on the top, 5 minus a negative 1, that would be the same as saying 5 plus 1, so that's a 6. On the bottom, negative 3 minus negative 7. Minus a negative 7 would be the same as plus. So really this is negative 3 plus 7, which is a positive 4. And finally, we would want to reduce that as much as possible. So 6 over 4, 6 and 4 are both even numbers, so they're both divisible by 2. So 6 divided by 2 is 3, 4 divided by 2 is 2. So my slope for the line that contains these 2 points is 3/2. We'll do one more of those together. Okay, same thing on this one. For my slope, I'm going to call the first point that they gave me 1 and the second point that they gave me 2. It does not really matter. All that matters is that I keep things in the same order. So I do y2 minus y1. And on the bottom, x2 minus x1, and then simplify. So 2 minus a negative 10, that would be the same as saying 2 plus 10. So that would be 12. On the bottom, negative 14 minus 6, that would be negative 20. All right, now we could reduce it. 12 and 20 are both divisible by 4. That would be the greatest common factor. So 12 divided by 4 is 3. 20 divided by 4 is 5. And now there was a negative in one part of this fraction. It's in the denominator, but that's not really a proper place to put a negative. So I'm just going to move the negative to the numerator. It comes out equivalent. It doesn't really matter where it's at. It's just not really proper to have it left in the denominator like that. So my slope for the line that contains these 2 points is negative 3/5. Okay, the next 4 problems that are on here would be good guided practice problems here. So this would be a fantastic place to pause the video and try these 4 problems and then come back and check and see how you did. Okay, welcome back. So you need to check your answers on all 4 of these. For C, the slope was 5. For D, the slope was negative 6/5. For E, the slope was 1/5. And for F, the slope was 6. I do want to point out on C that I said that the slope was 5. I did not say that the slope was 5/1. When you end up with a number and it's got a 1 denominator, you're working with a fraction and you get a 1 denominator, please don't leave that as part of your answer. It is unnecessary to put a 1 underneath it. So simplify it and make it just 5. I also want to point out on part F, both the numerator and the denominator on mine turned out to be negative numbers. And when you take a negative and you divide it by a negative, you get a positive. So I gave the answer as a positive 6 here. Once again, the denominator turned out to be a 1, but I did not write the 1 and present that as part of my answer. Okay, next up, we're going to be finding the slope of the line from a graph. And I'm actually going to do this a couple different ways. So first of all, I'm going to look at the graph itself and determine whether I think the slope should be positive or negative. Now looking at this graph, as I move from left to right on the graph, the line is going downward or falling. So that would be a negative slope. So I know it's going to be negative. So I'm going to go ahead and write down a negative right now. Now next, since I do have a graph and I've got distinct squares on here that I can look at, I can actually just measure the rise and the run straight from the graph in order to get my slope. So I'm going to go from 2 distinct points, 0, 5, and 3, 3 are the ones I'm going to use. And I'm going to draw in a little triangle, little right triangle, by putting in a vertical line segment and a horizontal line segment there. That connects those two points. Now all I have to do is count. So this side of the triangle has 2, and this side of the triangle has 1, 2, 3. This one's 3. So the rise is 2, and the run is 3. So my slope for this function would be a negative 2/3. Now, of course, I could also do this using the slope formula. And so I want to do that as well. Now, they gave me 3 points to work with on this function. I can use any of those 3. So I think just to prove that we get the same thing, I'm going to use 3, 3 and 6, 1. And I'm going to call 3, 3 my first point, and 6, 1 will be my second point. So 3, 3 is my x1, y1. And 6, 1 is my x2, y2. So when I fill in my formula, on the top, I need y2, which is 1, minus y1, which is 3. And on the bottom, x2, which is 6, minus x1, which is 3. And then I simplify just like before. So 1 minus 3 is negative 2. 6 minus 3 is 3. So I ended up with a slope of negative 2/3, which is exactly the same as what I got when I counted it from my graph. Right, our final concept today, which is very much related to slope, is the average rate of change of a function. The average rate of change is actually the slope of a secant line of a function. So let's talk about secant line real quick, because that's some new vocabulary here. The secant line is a line through two distinct points. So on the picture that I have over here, I've got two distinct points, this one and this one, on my function, which is this lovely curvy function here. And these are my two distinct points. We're calling them x1, and this is essentially saying y1. It's saying f of x1. The other one is x2, and then essentially this says y2. Okay, so if I drew a line through those two distinct points, that would be a secant line because it contains these two distinct points on my function. And the average rate of the change of this function on this interval from this x1 to this x2 would be the slope of that secant line. So for the formula, I would be saying f of x2 minus f of x1 over x2 minus x1. And just as a reminder there, f of x2 is is the y value of the second point, and f of x1 is the y value of the first point. So really, this is just the slope formula. It's just using function notation instead of y's. Okay, so we have an example here. We've got a graph to work with, and there are a few points that are drawn in on the graph, and they're labeled. They call this one A, and this one B, and this one C, and this one D, and this one E, and that's just for convenience, really. Normally, we would not label those points on the graph that way, but I wanted to make it so that we could make some sense out of the notes here, make it a little bit easier for you to follow. So the question says to find the average rate of change of the function on the interval of x shown by drawing the secant line. So I'm going to have to draw a secant line. The first interval that they want me to look at is from 0 to 1. Now this is talking about an interval of x's. So this is saying from when x is 0 to when x is 1. So looking at my graph, x is 0 here to x is 1 there. That's why it says from point C to point D. So this is my first one here. I'm going to draw in my secant line. And then for the average rate of change, I just need the slope of this secant line. So I'm going to find the slope using the points that I have here, the points that are labeled. So 0, 0, and 1, 1. So this would be y2 minus y1 over x2 minus x1. And when I simplify that, I get 1 minus 0 is 1 over 1 minus 0 is 1. 1 divided by 1 is still just 1. So the average rate of change of this function from x equals 0 to x equals 1 is 1. Now looking at my second one there, I want the average rate of change on this function from -2 to -1. So again, this is asking me for average rate of change between these two x values on this function. So when x is -2, that corresponds to this point here, point A. And when x is -1, that corresponds to this point, B. So this one is looking for the average rate of change from A to B. So I'm going to draw in the secant line as the directions told me to. Oh, that was really bad. Let me try that again. If I was doing this on paper, I would be using a straight edge because it comes out so much neater. Unfortunately, I'm stuck using this tool. All right, so here we go. I want the slope of that line. Now, at a glance, I can tell that the slope of that line is negative. So I'm going to be expecting a negative value here. And I'm going to do this the same way. Wow. I'm going to do this the same way that I was doing all the others. So I'm going to call this point up here 1, and I'm going to call this one 2 for my formula. So y2 is 1 minus y1 is 4. On the bottom, x2 is negative 1, and then minus x1, that's negative 2. And then I just have to calculate. Don't have enough room underneath, so I'm going to go sideways here. So I've got 1 minus 4 is negative 3 on the top. On the bottom, negative 1 minus negative 2. Now, minus the negative 2 is the same as plus. So this would be negative 1 plus 2, which is 1. And then finally, I ended up with a 1 denominator. And as I mentioned before, you don't want to leave a 1 as your denominator ever. So negative 3 over 1, I would just present that answer as negative 3. So my average rate of change of this function from x equals negative 2 to x equals negative 1 is negative 3. Okay, one more. We'll use pink this time. Okay, so this time I want the average rate of change from x equals 0 to x equals 2. So on my graph, x equals 0 is here, so that would be point C, and x equals 2 is here, so that would be associated with point E. So I'm going to connect the dots on that one, draw in the secant line. Oh, I missed. Let me try that again. There we go. Okay, and again, I'm going to call this one over here point 1, and I'll call this one point 2, just to keep the same process. Now, at a glance, looking at this secant line that I've drawn in here, it is rising from left to right. So I'm going to be expecting a positive slope this time. So let's just apply the formula now. So y2 minus y1 over x2 minus x1. So this would be 4 on top over 2 on the bottom. And I can reduce that. I'm just going to think of this as 4 divided by 2 because that's really the easiest way to figure it. 4 divided by 2 is 2. It is a positive 2, which is what I was expecting. It is rising from left to right, so I was expecting a positive value. So that means the average rate of change of this function from x equals 0 to x equals 2 is a positive 2. Okay, now there's one last question down here at the bottom. It says, using the graph above, on what interval of x would the average rate of change equal 0? And they give you a few intervals here to look at. So this would be the right place again to pause the video and think about this. Decide on your answer, or answers, I suppose it's possible there could be more than one here. And then come back and check and see if you got it correct. All right, welcome back. So for this one, for the average rate of change from negative 2 to 0, x is negative 2 here, and x is 0 here. I can tell just from looking at it, if I were to sketch in that secant line, that would have a negative slope. So the average rate of change on that one would be a negative number, which is not the same as 0. So I can say A is not the right answer. For B, x is negative 2 here, and x is positive 2 here. And if I connect those two, I see it's going to give me a horizontal line. And a horizontal line does have a 0 slope. So this one would be an answer. I do need to check the other two though. So from 0 to 1, from here to here, we actually calculated that slope already. But just at a glance, I can tell if I connect those, that's going to be a positive slope, which is not 0. And then lastly, I want to look from 1 to 2. So when x is 1, we're here. When x is 2, we're there. And if I connect those two, they do not make a horizontal line. So that does not have a 0 slope. That again would have a positive average rate of change. So B was the correct answer on this one.